Let's continue now to look at adding and subtracting fractions. Let's consider the following scenario. So, our first observation is that the denominators are not the same. What shall we do? Well, we learned in the previous part, our aim is to make them match. Look at these two numbers. Can you see a way they can match? Well, 4 is going to make 8 quite easily. So if I double both parts of the first fraction, then now I have the same denominator for both. So let's add those fractions. Okay, hopefully now you can see why I chose this example. Now, 9/8 is a perfectly good answer. If you remember from a previous video, this is an improper fraction. Can we convert it into a mixed number? Yes, we can. And we have to have that skill. So, look at the fraction and remind yourself what this denominator means. It means how many pieces are needed to make a whole one. Do we have enough pieces to make a whole one? Yes, we do. How many pieces do we have left over? Good. You'll notice now that I've stopped drawing diagrams and fractions has become mostly about practicing on paper. We'll go back to some diagrams later when we introduce new concepts, but for now this becomes just a written exercise. Let's look at the following. Now, here we're going to have to do several things. And you'll be taught, probably, very different ways by different people. And the answer is, none of them are wrong. But in certain situations, some will be better than others. So, first thing I'm going to do is to tackle these two numbers here. What do they add to make? That's right. That's 5. And I'm going to write 5 3/4. And then I'm going to just add 2/3 to it afterwards. So I've tackled this. Now let's deal with our fractions. We have denominators of 4 and 3. So let's work out where those times tables will meet. Twelve it is. Now, this 4 was 1, 2, 3. So I times both parts by 3. That gives me 9. Over here, it was 1, 2, 3, 4 I had to multiply by. So I times both parts by 4. Remember to multiply both parts. Okay. Now when I try and add the fractions, I get an interesting answer. And we saw this back when we tackled adding and subtracting with the same denominator. Feel free to go back and watch that video if it helps. 17/12 is not an answer we can leave in a mixed number. We know that 12 pieces makes up a whole one, and we have 17. So we actually have enough pieces to make one whole one. How many will we have left over? Take 12 of these away. Well done if you got that. So, my actual answer is, I had 5 whole ones and this. I had 5 whole ones and 1 and 5/12. So that's 6 whole ones and 5/12. Now these are getting trickier because we're having to use mixed numbers as well as improper fractions into our adding and subtracting. And in fact, if you can handle this question here, you're doing very well. Now, some people will say there's another way of doing this, and I'll show that to you later on. But let's look at a difficult subtraction question now. And this is where most people will come unstuck. Three and a quarter, subtract 1 and 5/6. So, first thing I'm going to do is I'm going to deal with these integers. 3 take away 1 leaves me 2, and a quarter take away 5/6. Now I'm going to make the denominators the same. 4 and 6, where do they meet? Well, they meet very early on at 12. To get from 6 to 12, I had to double both numbers. And to get from 4 to 12, I had to times both numbers by 3. So I've used my rule for adding and subtracting fractions. Something looks difficult about this next phase, because 3 subtract 10 isn't going to work easily. So, how am I going to do it? Let's visualise the problem. Here are 2 whole ones, and here are, underneath, 3/12. Now I need to take away 10/12. So how can I do that? Well, first off, I would take away these 3. How many more do I need to take away? Well, I've taken 3, but I had to take away 10. So I've still got to take away 7 more. So what I've got is, I've got 2 whole ones left, and I've got to take away 7 more 12ths. Now, we need to think of this next stage a bit like borrowing, because I'm going to have to borrow from one of my whole ones to give up the 7/12. So watch what I do. I've now cut my whole one up into 12/12. So I've now got 1 whole one and 12/12. And I need to subtract 7/12 from that. Well, that's no problem now. 1, 2, 3, 4, 5, 6, 7, which leaves me 1, 2, 3, 4, 5. So I still have one whole one and 5/12. Now this example is much trickier. Subtracting the integers was fine. You can do that, I'm sure. Converting to the same denominator, that's a previous skill. But it's recognising how to cut up the whole one that is trickier. And we'll go through some more of those on the next video.